In this video, we are going to cover Azure Cosmos DB Emulator and we'll try to write some code using this emulator. So let's first see what exactly is Azure Cosmos DB Emulator. So this is strictly going to be used for local development. We cannot use it for production use case. You do not need any kind of Azure subscription to use this Cosmos DB emulator, and you don't have to pay anything upfront. Also, because this is an emulator, so this is not capable of emulating every aspect of Azure Cosmos DB service. Like, it is going to have a limited container size and it is not going to have serverless throughput. Also, whatever request we are sending, it is going to get authenticated only using a key. So if you're just getting started with Azure Cosmos DB services, then this particular emulator will help you, because whatever code you are planning to write on Azure Cosmos DB services, same code you can try to write on your local, get it tested with Azure Cosmos DB emulator. It will make sure like you're not going to break anything and you will have your code tested already before you deploy on actual Azure Cosmos DB platform. So let's see like how to use this. So first of all, we have to go to this particular website, or you can also simply Google search it. You can just write Cosmos DB emulator and it will route you to this particular URL. Now here in this particular article, you can see what's the difference between emulator and cloud services. They have strictly written like we are not recommending to use the emulator for production workload, but we can use it for our development testing for all those activities. Also, you can see in this article what kind of restrictions we have on this particular platform. So we are going to have API for NoSQL and API for MongoDB only. This is only going to support the provision throughput, and this is not going to support the serverless throughput as we covered in our diagram. Also, you can see you cannot regenerate the key for the running emulator. So whatever key you are going to get once you start that emulator, that particular key only we are going to use it. Also, one of the thing, like it is going to have a fixed container size and fixed kind of throughput as stated over here. So 400 or RU per second or 5 unlimited size container we are going to get. Second thing, we need to see like how we are going to install it on our local. So there are particularly 3 ways. If you are on Linux, so there is a Docker container for that. There is a Docker container for Windows, and then you can directly install it on your Windows also. You can download this emulator from here, and it's a normal installation. You will get an exe that you have to just install it on your local. So once you install it, you can just search for it. You can just write Azure Cosmos DB emulator. You can see over here, and after that at the bottom you will see like you are going to get this particular icon. It states that Azure Cosmos DB emulator is going to get started, and one thing you have to notice, like it's going to start it on your local only. So I will just click on this, and I'm just going to click on Open Data Explorer. And you can see like it's going to give you this URL, and you can notice you are going to have the URI, you are going to have a primary key, there is a connection string for that, and then there is a Mongo connection string for that as well. Why there are 2 different connection string? Because this one is for NoSQL API. If you're planning to use Cosmos DB for Mongo, then you can use this particular connection string to connect to that. After that, at the bottom you can see there are sample code for different platform. There is a code for Java, there is a code for .NET Core, .NET, Node.js and Python. We are primarily focusing on Python. You can also refer to this. There is a documentation code sample and the tutorial for this. So this will give you the connection string, the URI, all those things which we are going to leverage to connect to this particular emulator. So let's go to our diagram again. We are going to use Visual Studio. On our local development environment, we have to install this particular dependency, Azure Cosmos. You can go to your terminal, pip install Azure Cosmos, and it will install all the dependency and all the services which we would be requiring to connect to Azure Cosmos. And because we are using emulator, we don't have any kind of other mechanism as of now. We are only going to connect it via keys. On the right side, I'm just trying to highlight like how this Azure Cosmos system is going to work and where our data is going to get reflected. Emulator is running on your local. So first of all, what exactly happened? You should be having an account. Under that account, we can have a multiple databases. Under databases, we can have multiple containers, and under containers, we are going to have items. So this is how the Cosmos DB work. You can just assume, okay, container is pointing to tables only, just for the understanding perspective. And under container, we are going to have item. Under table, you can have the rows of the data. So similarly, like we can have the items under container, which is going to signify what actually we are storing in Cosmos. And same kind of architecture is going to get followed on actual Azure Cosmos DB services as well. So there also you have to follow the similar thing. You need to have an account, you need to have a database created. After that, you need to have a container created, and then under container, you are going to have your items stored. So whenever we are inserting, updating or deleting any item, that is going to be under under container. And how this item is going to look like, so this item is primarily going to be of JSON format. So here you can see like this is one of the item. As you know, like JSON is going to be in the key and value format, and this can have any level of nesting. Also, just wanted to highlight one more thing. Once you go to Azure Cosmos DB services platform, I mean go to actual, not the emulator one, but actual Azure Cosmos DB services, we are going to get support under Cosmos DB, Cassandra, PostgreSQL, Table, MongoDB, and also this one is a native API, which they call it Azure Cosmos DB for NoSQL. But in Emulator, you can see we are only getting option for two things. One is for their native NoSQL API and another thing is for MongoDB. But once you go on the platform, the actual platform, Azure Cosmos DB platform, then you will have support for Cassandra and other entities as well. Let's go to our Visual Studio now. And I will just walk over actually what exactly we need to do. So first thing what I did, like we have to go to our environment file, and here we have to provide the Azure Cosmos Emulator details. We can also directly pass in the code, but if you don't want to expose it, like we can put it in the environment file and then load it from there. So here we have the Azure Emulator Cosmos endpoint. So this endpoint we are getting from here only. This is the URI. And second thing what I'm passing is primary key. So I'm just taking this primary key and putting it over here, Azure Emulator Cosmos key, and using these details, then I'm going into the code. I have created this new emulator.py file, and after that all this environment variable we can load it using the load_.env. So here it's coming from .env, and whatever values we have in the environment file, we just have to write this and it will load all the values from the environment file. After that there are two things as I have highlighted in the diagram as well. So we are on local, so we don't have to create like any specific account for this one. Under that we have to give the database and container name. So this is what actually I'm passing as a variable first. So what is going to be my DB name and what is going to my container name. After that actually we have to get the URL and the key. So this I'm getting from the environment variable which we have defined in .env file, and to retrieve the values from that environment file I'm using os.environ. So this would help me to retrieve the values from there and just assign it to these variables. After that the important thing is whenever actually we have to connect with Cosmos, we have to use this Cosmos client, and under this Cosmos client we have to pass the URL and the credentials. So here you can just pass the Cosmos key under credential and the URL. So here our URL is on our local only, so that is going to come into this Cosmos URL. So this is going to get assigned to this, and this Cosmos client is going to come from azure.cosmos. So that's why we need to install that Azure Cosmos dependency first, so that like we can get access to Cosmos client and partition key. So once we have Cosmos client, after that actually we have to define our partition key. In our use case, I will show you some data what we are planning to insert. Our data is going to look like this. Each and every record can be identified using this unique ID. So I'm using this ID as a partition key, and this ID is going to help us to distribute the data into different partitions. If you just go to this partition key, you can see it's using the hash kind of methodology to distribute the key, and you have to define a path. So under path you don't have to do much, you just have to provide the key on which actually you want to define your partition. So this I am storing in key path, and after that we have to create our database and container. So there is a method under this client create database if not exist. There is also one method like client.create database, but if not exist, make sure okay it will only create that database if it is not already available. You can see the details over here, the create the database if it does not exist already. Okay, and after this under that we have to pass ID, and this ID we are passing it from here. We have already defined the database name, so this ID we are passing it over here, and I'm just printing that information on this, like once the database has been created we are going to get that ID printed on this. Similarly we have to define our container just to follow this particular diagram. So database, container, and that we are going to have item. So before actually we start inserting any item, we need to have the database created. Under that we need to have a container created. Second option is this. So that's why you can see, because container is going to get created under databases, so whatever database we have got from here, we are going to use that database to create container. So notice this, first we are using the Cosmos client to create database, and then using this database to create container. Again we are using same thing, create container if it doesn't exist, and under that we have passed the container name, we have to pass our partition key which we have defined, this key path, and at the last you can see offer throughput also. Let me just cover this offer throughput, what exactly it is, because if you are dealing with Cosmos DB, then you will see this term a lot. So let me just go over that, like what exactly is this. The offer throughput will help us because as you can see, like a database can have multiple containers. So this particular offer throughput allows you to reserve a certain amount of throughput for your database or container. Suppose, okay, you have multiple container and what particular container is very heavy process container, I would say, where you are reading and writing a lot of data. So you can just define some higher throughput under this. Your charges are going to be dependent on this offer throughput. So if you are increasing this throughput more, then eventually your charges are also going to be higher. It will reserve those throughput for this particular container or database. This particular throughput is being measured in request unit per second, that is called RU per second. And there would be often chances, okay, you can probably define some kind of RU at the starting, but based as your container or as your database, you may have to increase it further as well. And there are certain points that you need to remember, because each request that goes to your Azure Cosmos DB container or database, such as read request, write request, stored procedure, or have a corresponding cost. Suppose actually you have defined 400 RU per second for your particular container and you are just reading from that particular container, right? You are reading your items from that particular container. So each request is going to have a certain cost linked with that, and every time when you are making a call, it's going to get detected from your throughput only or from your RU only, which you have defined. So suppose you have provisioned 400 RU per second, and that you can provision by defining it over here. So it could be 400, it could be 100, or it could be 1000 or 25,000. It depends on you. So suppose, okay, you have provisioned this 400 RU per second and issue a query, right? It means in a second you can only request for 10 such queries and not beyond that, because after that you won't be having enough RU or enough throughput. In that sense, what would happen, like it's going to get rate limited and your end consumer is going to get an error. So in that case, they won't be able to make a call because your container RU has been exhausted. So in that case, actually they are going to get an error and they have to retry those requests. So this is the concept of offer throughput or RU, which you are going to hear a lot when you are working on Azure Cosmos DB. So now you have your database created, your container created. I have also printed container ID over here. Now we are trying to insert an item over here. So you can see it's going to have an ID, title, author, genre, price, and published year. It's in the JSON format, and this is how actually we are trying to create an item under a container. So I have my item defined over here, and I'm just going to call container.createItem new underscore item. So let me try to run this code. And you can see like I have got some warning over here, but you can just ignore it. So you can see I'm getting some warning, but you can ignore it. So let's go to our Azure Emulator and see whether this particular item has been created or not. So to explore your database container and everything, you have to click on Explorer. I'm just clicking on Explorer and I can see the test DB has been created. The test DB is same thing what I have defined over here under this for my database. So under database, we should be having a container with person info. So and you can see person info, and under this I should be having items. So once I click on items, I should be able to see one particular item. So here you can see ID. I'm just going to click on this and I can see my item got inserted into this. And if you want to run a query on this particular container, then you can do so as well. You have an option over here, new SQL query. You can just click on this and you can just go ahead with this. Like I can just go ahead and run this, and you can see like I have gotten the same result over here as well. Just note that like you don't have to write person info over here, like going to refer to this only, and you can just directly execute it. So this is how actually you can create an item using a Python. And now we will go to our next step. So I will just comment it out this part and I will try to bulk insert items now. So there is no particular API to bulk insert items into Azure Cosmos. So we are going to follow similar programming pattern where we are going to have a file with full of JSON. We have to go over the item one by one and then we have to insert it using the same method. This code is for bulk insert, and you can see all the items have been listed over here. So it's ID2, ID3 in the similar pattern, whatever the data we have. And I will try to insert all these items at once because this I have stored it in the JSON file. So I am just using simple Python code. I'm just opening this file and getting all the items. And once I have all the items, I'm just looping over it and using the same method which we have covered over here to insert all these items. So let me try to run only this particular section of the code. Again, I have got some warning, but that's fine. I can go over here and see. So I can click on this on the refresh part, and you can see I have got all these items now. If I click on 12th item, I got this 8th, I got this. Similarly, like I can query this as well. Again, I'm just writing a query, going to execute query, and I can see like I'm getting all this result all together. All the items have been inserted into this. So other possible use case would be if we have to retrieve an item from our container, and this actually we can use it to retrieve each and everything, or retrieve a specific ID from a container. Here actually I'm just trying to show what if we have to retrieve only one particular item from a container. For that actually we just have to write a query for this, and you can see select a star from person info, and this ID is going to be variable. The ID what we want to retrieve value of is ID3, and that particular ID, because this is a variable and this is where we are defining it, so we have to map it accordingly. And for that actually we are going to use this param variable, and here you can see like we have just defined a dictionary where the name is going to be this particular variable which we have defined, and the value is going to be this one which we are passing. So once you have this, then there is another method for container. So as of now we have created create item. There is also another method query items. So in this query items we have to pass our query. This query would be this, and after that because we are passing a variable along with that query, so we have to pass it under parameters. So under parameters you can see this particular param is going to get passed, and after that, because using that partition key only, our data is going to be splitted into multiple partition, and we want to query along all those partitions. So that's why enable cross partition query, we have put it as true. Once we get a results out of it, and like if you want to put it into a specific format, so that's why actually I'm just taking the items from this result and then just dumping it using json.dumps and just printing the out. Yeah, so let me try to run this and see what exactly we get. Now you can see here for ID3 I have got this output, and let me see what do we have in the file. So yeah, so it's the same result, and similarly actually we can check it on our Cosmos DB also. So you can see for ID3 we do have a same result. So this is how actually we can retrieve the value. Now, so we queried for a single item here by passing a particular ID, but what if we have to query for, multiple items? If we have to search for more than one ID, then we can go with in operator. Same thing actually we have to do over here. So in this case, you can see I'm looking for two IDs, ID3 and ID4. And same thing, I'm just passing over here using this in operator. And then in param, I'm just assigning these values. So in ID1, I have 3, in ID2, I have 4. And I'm just assigning 2 dictionary parameters. Everything else is going to be same only. We are still going to use this container query items, and we are also going to print it using this particular code which we have used earlier also. It's just that earlier when it was going into this list, then it was only able to find one item, but in this case the result variable will hold like 2 particular values, and that is what we are going to print it over here. So let me try to run this now. And you can see like this time we have got 2 items. One is for ID3 and second is for ID4. This is how actually you can use this particular code to look for multiple items as well. The last thing what I wanted to explore is upserting an item. So if the item is available with the same key, it's going to get updated, and if it is not there, then it's going to get inserted. So in this case, like I'm going to take a new item. So I can just write new item 1. I'm going to have an item from here, and I will try to just update one thing out of it. So probably I will just copy this and put it over here. Let's say I want to change the pricing of it. So instead of 9, I just want to make it 19. It is very easy to do it using Python. So what we have to do, because it's going to be container operation, so I'm going to use the container, and under container you can see all these options over here, and you can see upsert item. So what I'm going to do, upsert item, and just pass this new item 1, and we'll see whether this particular value is being updated or not. I will just comment it out earlier code. Yeah, so got some warning, but that's fine. So let me go to our Azure Emulator, and let's try to go to items. Let's try to click on 4 and see the price has been updated as $19 instead of earlier $9. That's how actually we can perform all these operations using Azure Cosmos DB Emulator. It can give us a playground, or you can see a sandbox to test out our queries to see like everything is working fine. And similar thing, then we can go ahead and replicate it on Azure. There are several options you see, like there are options for triggers. So we can use triggers, we can create triggers, we can, define our functions, the procedures. So this is something that which I will try to cover later on. Another thing I just wanted to highlight is scale and settings. So you can see the throughput which we have defined in our code. So based on the throughput, you are going to get charged once you actually go on the Azure Cosmos DB platform. And here there is a capacity calculator for this. So you can see for the throughput, what would be your charges per month. So here you can see we have cost per GB per month is going to be $0.25 USD. Total data stored per region, they are considering 10 GB. So estimated storage cost is going to be 2.5 USD. After that, the transactional load, the cost per 100 RU per hour, request unit per second per hour is going to be 0.008 USD. And this is important because this cost is going to be driven based on your RU. So because we have defined the 400 RU, the minimum throughput is going to be 400 RU only. But if increase this number, then your charges are also going to get increased. There is a direct correlation between your container or database RU and the cost that you are going to pay to use these services. So here you can see like still we can utilize all this thing without paying anything, without having any service charges. You can see an option over here to create actual Cosmos DB account. But just wanted to show you like this is how it's going to look like. Other thing what we have over here is a scale. Then we do have some settings and then the indexing policy. Yeah, so I guess this is what we have for this video. If you have any question, write down in the comment. I would highly suggest to go on and try this emulator, try to write some code, hit it using different scenario. So yeah, so that's all for this video. Thank you for watching.